Pre-statistics, graphing quadratic functions in standard form. Lesson objectives: graph a quadratic function in standard form by using the Vertex formula and also using the graphing calculator. Number 2, find the minimum or maximum value of a quantity. Lesson objective: axis of symmetry. The axis of symmetry of a parabola is the vertical line that divides the parabola into two congruent halves. The formula for the axis for a quadratic equation in standard form, and if you recall, the standard form is f of x equals ax squared plus bx plus c. A, b, and c are coefficients, and the formula for the axis of symmetry is x equals negative b divided by 2a. So I take the value of b, I change its sign, then I divide it by 2 times the value of a. As we can see, the parabola is symmetric about this axis of symmetry, and somewhere on this axis of symmetry is the vertex. It will either be a minimum value of the function or a maximum value of the function. So let's go over the process. To find the vertex of a graph of a quadratic function in standard form, number 1, we find the x-coordinate of the vertex by using the vertex formula, and that is x equals negative b divided by 2a. Number 2, to find the y-coordinate of the vertex, we evaluate the function f using the value that we found in step number 1. That is, we want to find what is f of negative b divided by 2a. So this is how we do it algebraically. We'll also do it graphically and numerically. So let's do an example. Example number 1. Find the vertex of the graph g of x equals x squared minus 4x plus 7. We'll do this algebraically first using the vertex formula, and then we'll use the graphing calculator to find it numerically and graphically. So solution: so a is 1, b is negative 4, c is 7. Substituting these values for a and b into the formula, we get b is negative 4. We take the opposite of negative 4, and then we divide that by 2 times 1, which is 2. So 4 divided by 2 is 2. So the axis of symmetry is x equals 2. To find the y-coordinate, we go to g of x and we substitute 2 into the function. So we have g of 2 equals 2 squared minus 4 times 2 plus 7. We square first, we get 4. 4 times 2 is 8 plus 7. 4 minus 8 is negative 4. Negative 4 plus 7 is positive 3. So we have both the x and the y coordinate for the vertex, and the vertex is 2, 3. Using the graphing calculator, we can graph it and find the vertex using the minimum command, and then we can also do it numerically using the table command. So we have our graphing calculator. We go to the y equals, make sure your stat plots are turned off, type in your function for g of x, so that's x squared minus 4x plus 7. I'm going to hit zoom, and number 6 for zoom standard. We can see it in this window setting. So now we want to find the location of this minimum value. So one way of doing that is using the minimum feature. You go second and trace, which is calculate. Number 3 is minimum. Okay, the first question the calculator is asking, what is the left bound? So we want to pick a number that is to the left of the minimum value. So this looks good to me. I'm going to hit enter. Next it asks what's the right bound. So now I need to move my cursor to the right of what I believe the minimum value is, and that looks pretty good. Hit enter. Okay, now it wants a guess. I'm going to move the cursor to where I believe it is, and the guess is like about 1.9 something. Hit enter, and the calculator comes back as 1.99999. Now rounded off, this is 2 and our y value is 3. So it's sort of estimating. Now if we want to be more precise graphically, we can change the window settings, zoom in a little bit better, and it'll get a better estimate. I don't think that's really needed for this problem. I think clearly it's going to be 2, 3. But let me go ahead and show you how to do that. So if I go to Window, I know the value of the vertex is around 2, so I'm going to let my x-min be, say, something like -1, and I'm going to let my x-max be, say, around 5. So 2 is about in the middle of this, and I can count by, let's say, something smaller than 1, let's say 0.5. You can use 1, it really doesn't matter in this case. For my y-min, it did not cross the x-axis, but I'm still going to use, say, -1 for the y-min, and for the y-max I'm going to use, let's say, 5. And again, I want to count by 0.5, and let's see what this looks like. We hit graph. Okay, we see a little bit better picture of the parabola. So now when I go back to second and trace, number 3, okay, I'm going to scoot it to the left a little bit. For my left bound, hit enter. Scoot it to the right. If you notice, these little triangles sort of come up, and that's to tell the calculator this is sort of the domain, and in that domain look for the smallest value. Now as far as the guess, I'm going to say something like 2.06. Hit enter, and the calculator now gives me an estimate of 2.0000, which is pretty much 2. If we need to be more precise, we could zoom in closer. Now to do this numerically, I can use my table command, and before I do that, I'm going to go to table set, which is second and window, table set. I want to start at 0, that's correct, and I want to count by 1. So let's see what it looks like numerically. So the table command is second and graph, and we're starting at 0. So if we go to the left of 0, we can see these numbers, the y values are getting larger, and if we scroll down, the numbers are getting smaller. When x is 2, y is 3, and then when we go, when x is 3, y is 4, here we can see the numbers are now getting bigger numerically, and we can see that these points are symmetric, and it looks like, it appears that our smallest value occurs when x is 2, and that smallest value is y is equal to 3. Let's do another example. Example 2. Sketch a graph of f of x equals 2x squared plus 10x plus 7. We'll approach this algebraically first. So solution, in this case a is 2, b is 10, and c is 7. So for the x coordinate of the vertex, we take our value of b, which is 10, take the opposite, so we have -10 divided by 2 times 2 is a -2.5. To find the y coordinate, we substitute this value, -2.5, back into the function. We square first, then we multiply by 2, then we multiply, then we add. That value should be -5.5. So our vertex is -2.5, comma, -5.5. So now that we have our vertex, we want to find some additional order pairs to sketch the graph. So I'm going to pick a few endpoints. The first one, -2 for my input, substituting that value in for x in my function, and following the order of operation, I have to square first, then multiply. I get 2 times 4 plus 10 times -2, which is -20, plus 7. A input of -2 gives me an output of -5. My next input's -3. -3 squared is 9. 9 times 2 is 18. 18 plus negative 30 plus 7 gives me an output of negative 5. Next, I'll try negative 1 as my input. Following the order of operation, my output becomes negative 1. Finally, my last input, negative 4, gives me an output of negative 1. And again, here we can see the symmetry in this parabola. With an input of negative 4, negative 3, negative 2, negative 1, I get the corresponding outputs negative 1, negative 5, and negative 1. The vertex is somewhere in between negative 3 and negative 2. Plotting these points on graph paper, here we have our vertex at negative 2.5 and negative 5.5, and then here we have the corresponding 4 points that we just computed. Now that's how we do it by hand. We can also use the graphing calculator to sketch this also, and that's what we'll do next. We go to the y equals, we type in our function 2x squared plus 10x plus 7, hit zoom number 6. Okay, the vertex looks like it's about here. I can again use the minimum feature. Now I know this is a minimum value, because it looks like it's the minimum value, but also because this is a quadratic and the value of a is positive, it's a positive 2, I know that there's going to be a minimum point. When a is negative, we will have a maximum. So if I go second trace, number 3, okay, it's wanting a left bound, so I'm going to go to the left of the spot that I think is a minimum, hit enter. It is wanting the right bound now, so I go to the right, hit enter, and again, here's my little triangles. They're telling me it's only looking in between these two spots, and it's wanting a guess. So I'm guessing about negative 2.55, hit enter. And the calculators are returning negative 2.500001. The y value is negative 5.5. Now if I needed to be more precise, I can change my window settings or use a zoom in command and get closer to this vertex, but for this problem it's good enough. Numerically, if I go to table, here I can see the numbers are getting larger. So if I back up, I can see when x is negative 3, we have negative 5. When x is 2, we have negative 5. The table is telling me that this is the smallest value now, but we're counting by ones. If I go less than negative 5, these values are going to be bigger. So the vertex is somewhere between negative 3 and negative 2. So if I go second and window, which is table set, let's have it start at negative 3, and let's count by 0.1. Go back to table, and here we can see when x is at negative 2.5, this is our smallest value. This is the minimum value in the table. So we have verified it numerically. Thanks for watching.